C, A, E, I gamma x minus CT, and Y comma TT equal to I gamma C square. A, E, I gamma x minus CT. So this will be giving minus gamma square, A, E, I gamma x minus CT. And this will give me minus gamma square C square, A, E, I gamma x minus CT. Okay? Both have a minus here. So put the same thing, you can get, and here C defined as omega over gamma. Okay? So this is what we call the group velocity. Sorry, phase velocity, right? It should be I forgot, it's a phase velocity, suppose phase velocity, right? Then you can have same relationship as what? Yeah, you will have C square equal to C0 square 1 plus K over T gamma square. And or we have a gamma square equal to K over T. K over T. And C over C0 square minus 1. Right. Okay. Okay, so further you can use C equal to omega over gamma. This relationship you put into here. You can further get gamma square equal to omega square C0 square and omega square minus K C0 square over T, or omega square equal to KT C square C over C0 square minus 1. Yeah. So either one is the same, okay? So they can interchange. This is using the gamma, omega, and this is your gamma and C. But we also have the wave speed as omega over gamma. Okay? So you can do all the interchange. All right? So the physical meaning of this is a harmonic wave of frequency omega can propagate along a spatial velocity c, as is governed by the omega as a function of c. Yeah. Propagate the frequency of this mode. Propagate with a c. Okay. For different omega frequency wave, it will propagate its different speed for this frequency. Yeah, for a random wave, it can compose by a lot of frequency omega wave. So each component will propagate by its own speed, c. So the shape of the waveform will change. Okay? Yeah, will change. We have discussed this before. Yeah. Okay. Okay. So let them write down. Okay. So, for example, if a pulse of this form, okay, x, yeah, if a pulse is okay. For example, this pulse is a PT something, and this is if you go to the FFT omega, so this is a P bar omega. So maybe like a spectrum, something like this, right? So you have a different omega. So each omega, the omega is with speed. So the omega square is equal to kt c square c0 square minus 1. So that means the omega is function of c, or inverse, the c is a function of omega. So different omega will have different wave speed. So for the, if on the wave, the shape is x, so initially at time t, for example, we have a waveform. So each waveform has a different component oscillation, yeah. So this, each one have an oscillation, this is at time t oscillation. So afterward, each component will propagate different shape. So maybe it will change the shape to something. So distortion, that's why we call it's dispersive wave, because the form, waveform will change. Note it's X domain, okay? Waveform shape. All right. And okay. Yeah. Yeah. So let's see further to see what we have for this relationship. So the gamma square equal to omega square over C0 square minus K over T. So gamma will be plus or minus omega over C0 square minus K over T square root. Okay. So this root, if this is positive, then we'll have real roots, right? So first one, the root is real. So if omega square over C0 square minus K over T larger than 0, we have real roots. Okay. Then the waveform, the solution, y xt become a e minus I gamma x minus omega t, right? Become a e okay, plus or minus gamma. It's gamma. Okay, of this form. Okay. Yeah. So this is rightward propagating waves, and leftward propagating wave, right? Positive and negative. Same sign or opposite sign means backward and forward. Yeah. All right. So this is first one. Second, if omega squared over C0 squared minus K over T is less than 0, then we have imaginary roots. Okay. Then we define the gamma bar square equal to minus R square, gamma square. So our gamma is plus or minus I gamma bar. So gamma bar is a real number. Okay? And gamma is imaginary solution. So you put it back to the waveform. So we'll have y equal to a e I gamma x minus omega t. That will be equal to a e I gamma, okay, plus or minus I gamma bar x minus omega t. Right? So this will become become a e minus a plus gamma bar, right, x times exponential minus I omega t. Okay. It's different, okay? So this is a cosine minus omega t plus I sine minus omega t, right? So the oscillation is on the part, but no changing as time, the amplitude will not change, depending on location, okay? Each location, its amplitude is fixed, but and adjust by this coefficient different time. Okay, so this is standing wave. This is a standing wave, no propagation. It's just standing wave at some nodes. Okay, as before. Yeah. So for this one, we have a real roots, then it's propagating wave. But for imaginary solution, it's a standing wave. Okay? Yeah. Maybe right here. So for this one, note y equal to a e plus minus gamma bar x e minus I omega t. Okay, so you can see this is this kind of amplitude at different x. So this is a x, okay? And each node, it will have its amplitude, something like this. It's bound, something like, for example, and it just oscillate, sine, cosine here. All right. So this is what is spatially 空间的 spatially varying but no propagating. Disturbance. Okay. So this is for the imaginary solution. Yeah. Now the third case. Third case. Okay. If omega square over C0 square equal to K over T, okay, then gamma is equal to 0 at frequency equal to C0 square root of K over T. Okay, so we call this a cutoff frequency. Cutoff frequency. Yeah. Okay. And this is nothing to do, no space variation, just vibration. But after this frequency, it will change to some propagating mode or what. Yeah. Okay. Let's have a break. Okay. Yeah. Then we continue. 好，我们休息一下。